Next, enantiomers. So, to exhibit optical activity, generally molecules does not possess any elements of symmetry. So, different elements of symmetry are there: plane of symmetry, axis of symmetry, center of symmetry. So, all these are different types of elements of symmetry. So, to exhibit optical isomerism. Optical isomerism is due to the presence of chiral carbon atom. Okay, asymmetric carbon atom. So, to exhibit optical isomerism, no elements of symmetry is present in compound. Okay. So, generally, in optical isomerism, we get a pair of compounds which having the chiral carbon. So, that pair of compounds, they are mirror images to each other and they are non-superimposable with each other. Okay. So, enantiomers are isomers which are mirror images and non-superimposable. So, non-superimposable mirror images, they are called as enantiomers. Okay. Non-superimposable mirror images are called enantiomers. Non-superimposable mirror images are called enantiomers. For example, lactic acid is there. Okay. So, lactic acid that exists in two isomeric forms. One is dextro and another one is levo. Okay. Dextro and levo lactic acid. Coming to dextro and levo lactic acid. Carbon, OH group, hydrogen and COOH, CH. Okay. So, this is the structure of lactic acid. And this is L-lactic acid. Okay. And mirror image of this. Okay. Mirror image of L-lactic acid. COOH, OH, CH3H. So, this is D-lactic acid. D-lactic acid. This is L-lactic acid. And this is D-lactic acid. Both are mirror images to each other. Okay. But these two are non-superimposable when we place the compound L-lactic acid over it. Only COOH and CS3, they get superimposed, they get coincide with each other. But these two groups are not coincide, not superimposable. So, non-superimposable mirror images, they are called as enantiomers. Okay. So, enantiomers are non-superimposable mirror images. For example, if we take 2,3 dibromopentane, 2,3 dibromopentane, 2,3 dibromopentane. Okay, Fisher projection formula. I am giving Fisher projection formula here. So, if a mirror is there, mirror image of this, okay. So, both are mirror images but not superimposable mirror images. That's why these are enantiomers. Okay. So, enantiomers. are non-superimposable mirror images. Next, coming to diastereomers. So, diastereomers. Enantiomers are mirror images but non-superimposable. Whereas diastereomers are isomers which are not mirror images and also non-superimposable with each other. Okay? So, non-superimposable non-mirror images. Isomers which are non-superimposable non-mirror images. They are called as diastereomers. Okay? So, non-superimposable non-mirror images. Non-mirror images are called diastereomers. Okay? For example, if we take 2,3 dibromopentane as example. So 2,3 dibromopentane. So this is the structure of 2,3 dibromopentane. Carbon 1, 2, 3, 4, 5. Okay, second position and third position having bromine. Okay, if we write this same structure like this. Okay, so these two are having same molecular formula, but here both are not mirror images with each other. Okay, so if bromine is present this side, left side, they are mirror images with each other. But position of bromine here is at the right side. Okay? That's why these are not mirror images. Okay? And not superimposable with each other. Okay? So, non-superimposable, non-mirror images. They are called as diastereomers. Diastereomers. Okay? Next, racemic mixer and meso compound. Racemic mixer and meso compound. So you know that to exhibit optical activity, chiral carbon is must. Okay? So carbon which is asymmetric in nature, that is must. So if a compound having chiral carbon, that compound does not exhibit any optical activity. Okay? Even though it having chiral carbon, but there is no optical activity is present in that compound. Okay? So no optical activity is observed in a compound even though it contains chiral carbon in it. But we know that chiral carbon is responsible for optical activity. Okay? So such type of compounds are meso compounds. Okay? For example, tartaric acid is there. First write the meso compound. Meso compound is stereoisomer which does not exhibit optical activity though having asymmetric carbon. Okay? So this is due to the presence of plane of symmetry in it. Okay? So meso compound. Meso compound. Stereoisomer does not exhibit optical activity even though it contains Chiral carbon is meso compound, and this is due to presence of plane of symmetry. Presence of plane of symmetry.